Having said that, since data science is such a vast topic, and even I am personally learning it on day-to-day basis, learning new things, I would strongly recommend you to please read the articles and other additional reading materials that I will be providing in the additional sections. This is just because this area is so vast that I won't be able to cover each and every concept. But what I'll do is at least I will cover all the important concepts that can help you get started. Finally, I would like to say that at the time of recording this course, more than 150,000 people have already enrolled and taken my previous courses. So thank you so much for all the encouragement, questions, feedback, and suggestions. All right, so let's agree on some ground rules. Since some of the concepts may not be new for you, please feel free to skip to the next lesson if you feel so. If you feel that a concept is going a little fast for you, I would encourage you to rewind and watch this lecture again. Remember, no question is a dumb question. Feel free to ask questions in the forums. We are here to help. Finally, many people have asked me to add some reading resources. I will upload this document as a PDF and also add some useful resources as additional reference. Hope you like the course. So, see you in the next lecture. Welcome back to chapter number 2 on data science using Python. Firstly, before I start, I want to let you know that there are no prerequisites for this course. I will show you step by step and furnish all information and reading materials that is necessary for this course. So what exactly will we cover and what is machine learning? So machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. So say for instance, you have a set of data and you're trying to derive some knowledge out of it or test some hypothesis over the data. So there are lots of predefined algorithms that help you to do that. Precisely, that's what we call it as machine learning. So don't worry too much at this time as we will start looking at some examples and things will become more and more clear. So consider this little diagram, right? So what does this diagram really tell us? So if you look at a machine learning perspective from, say a 50,000 feet view, all it is just some input data that we supply to an algorithm, and the output is a few predictions or a few patterns, right? So it's as simple as that. But let's take a step back. So what are these algorithms that we talked about? So do I have to like invent any algorithm that can churn through my input data? The answer is no. These algorithms are already been written for you. All you need to do is supply some of the input data to it, and these algorithms will output the patterns and predictions. All right, so exactly what is the catch? Well, there's no catch as such, but if you think about it, there are two main aspects in this whole equation. One is choosing your inputs, and second is choosing your algorithms. This is where the actual skill sets and domain knowledge comes into play. So for algorithms to work effectively, it is essential that your inputs are clean and relevant. I will reiterate that your inputs should be relevant to your algorithm. Cleaning and manipulation of inputs play a very major role in the performance of your algorithms. So if your input has about say 1,000 rows, the algorithm may or may not work effectively. In this course, we will exactly learn how to choose these inputs and how to clean the input and make it relevant so that we can feed that to the algorithm more effectively and so that the algorithm can provide you with the correct results. We will also learn how to choose the correct algorithm and package this all together. So Python provides some methods and techniques that helps you choose which columns from your inputs would be more effective for the algorithm to perform at its peak. So once you have correctly chosen your inputs, it is now time to choose the correct algorithm. Now there are plenty of machine learning algorithms out there, and we need an effective way to choose which algorithm will work best with a given set of inputs. So in the coming lectures, we will be precisely looking at those things. That is how to clean up your data, how to choose your input, and how to choose the most effective and optimal algorithm that can work against your input data and produce the output and most accurate predictions. Now, at a high level, there are various types of algorithms, as well as we will kind of even look at these algorithms one by one. We'll also see how different combinations of the columns as inputs can provide drastically different predictions and different patterns. So to summarize, machine learning is nothing but supplying some inputs to an algorithm and churning through that input to output a pattern or a prediction. So your algorithm will be only as much accurate as your input data is, and the algorithm that you have chosen in order to work on that input data. All right, so once this concept is a little clear on your mind at a very high level, let us go one step deeper. I keep talking about these algorithms. So what are actually these algorithms and how many algorithms are out there? So at a very high level, machine learning algorithms can be broadly classified into two types. One is called supervised learning and another is called unsupervised learning. So supervised learning is nothing but you have the input data and you have the output data, and you supply both of them to the algorithm and let the algorithm study the patterns in the data, so that in future, if there is a similar input that arrives, the algorithm can actually kind of predict or try to predict the output, right? So let's look at this particular diagram, right? And then this is basically a machine learning problem which is called email spam classification, right? So think about your normal Gmail or any other email program that you're using. Google intelligently classifies all your emails into non-spam and spam. So naturally what it is doing is it is taking the input, your email message as the input, passing it to an algorithm, and the algorithm is actually telling Google that, hey, this is a spam message and this is not a spam message, right? And it's quite accurate. If you kind of look at your spam inbox, you can see how accurate it is, right? So how does this really work? So you can feed the following input, that is emails, into the supervised learning algorithm and let it study, right? So let us say this is your input, right? So if you see, this is where the overall trick of domain knowledge and using correct input data comes into play. Your input, if you think about it, is just a simple text message, right? An email message. And what we have done is we have kind of broken that a little bit, right? From that email message, we have taken some text, we have taken the from address, we have taken the to address, we have seen how many spelling errors are there in the email address, we have seen how many external links are there, and then we have classified it as yes or no, spam yes or no, right? So this is basically your input and output data that you will be supplying to the algorithm. So if next time, if a similar input comes, it can try to predict whether it's a spam or not, right? So that is why this whole concept of input, algorithms, the way the data is cleaned up as input, and the way that it needs to be supplied to an algorithm is very, very important. So I hope you're getting the message so far, right? Supervised learning is nothing but algorithms wherein you provide the inputs and also provide the outputs and let the algorithm study the relationship between the two, right? And then also the patterns between the two. So in future, if a similar input comes in a similar pattern, hopefully the algorithm would be able to predict the output. So there you go. You now know what at least one type of machine learning algorithms. And there are various algorithms in supervised machine learning as well, which we will look in the coming lectures. So the goal of this lecture was to give you a very high level view of what exactly is machine learning and what are the types of machine learning. All right. So moving on, the next one is unsupervised learning. So unsupervised learning is kind of the little opposite of supervised learning, right? So in supervised learning, we had inputs and we had also the outputs that we supplied to the algorithm and established a pattern. However, in unsupervised learning, we don't have any output. So the algorithm will just study the inputs and then classify them according to certain categories or clusters. So don't worry too much about it right now. We'll look at a very practical example in the coming lectures. All right, so there we are. We now know what is machine learning. It is nothing but providing set of inputs to an algorithm and deriving some knowledge out of that. And in this whole process, there are a lot of algorithms that help us do that. And these algorithms, work on text data, and there are specialized algorithms that work on numerical data. Some algorithms can work on videos, pictures, etc. So in the next lecture, we will take a deeper dive. We will look at some tools which will help us do this. We'll look at some packages in Python which will kind of help us run some of the algorithms. So we'll take it one step further and see what's in it for us. Thank you. Hey guys, welcome back. In the previous chapter, we learned what is machine learning, what are the input data that we supply to it, and how do we use that input data to supply to some sort of an algorithm that goes through the data and either produces a pattern or categorizes into certain categories. Please remember this very simple framework throughout. That is, you have input data supplied to an algorithm, and the algorithm basically outputs a predicted value or a pattern. Now, this is a very high level 50,000 view of what is machine learning. Now, in this lecture, we are going to look at how to set up some tools that help you run some machine learning algorithms. We will be using Python, and in Python, we will be using a statistical package called Scikitlearn. All right, so what is Python? Python is simply a programming language, right? So you must have heard about programming languages like Java, C# and others. Now, Python is simply another programming language that is very simple to learn and has very readable and clean syntax. Now, believe me, if you're new to Python, you will enjoy learning this particular programming language. Now, let me be very clear that the goal of this course is not to learn Python from scratch. Right? I will provide you with some resources that you can use to get acquainted with Python. I will make every attempt to explain the context as and when we go through this course. So if I use a particular keyword or a particular line of code in Python for data modeling and machine learning, I will try to explain what those objects and all those keywords stand for. Now, if you're completely new to programming, you might find some of the concepts a bit overwhelming. Now, if that happens, I would suggest you to hang in there and keep web searching or reading the materials on Python that I will be providing. Now, since this is not a Python specific course, you are expected to do some additional reading. If some of the syntax on Python or concepts are not clear to you, please pause the video and definitely read up or ask your questions in the forums. All right. So when you work with programming languages like Java or C#, you have also heard about tools like, say, Eclipse, NetBeans, Visual Studio. Now, these are all called as integrated development environments or IDEs. Now, these things in a lot of ways make your programming very, very easy. Similarly, Python also has many tools. Now, we will be using some of them as and when we move further along the course. We will be using the Anaconda distribution of Python. I will be showing you how to set up that environment, and also I'll be showing you how to write your first line of code. Now, what is Scikit-learn? Right. So Scikit-learn is a package or a library for Python which helps you to clean up the inputs and helps you supply them to the algorithm. In short, the statistical package, also called as Scikit-learn, helps you design machine learning models very easily without writing too much code. Now, I have given some documentation as well. I would recommend you to just skim through these materials so that you are actually aware of what we are talking about. So we'll definitely go through things like NumPy arrays and all those things, but definitely just to get acquainted with this, have a glance through this and look at the documentation as well. so that you know what we are talking about. Now, I will also show you how to install this whole Scikit-learn packages or library and write your first line of code. After you have set up all your environments correctly, we can then look at what are the different algorithms or machine learning algorithms available, and what are the ways in which you can clean up your inputs and then apply machine learning concepts or techniques in order to model the data. In order to go ahead and get started, I would say definitely download the Anaconda distribution. So I've given the link. And definitely go ahead and install it. It's pretty straightforward. Exe, just keep clicking next and install it, so that in the next lecture I can kind of walk you through some of the basic syntax, some of the basic code that you can start writing. So we are pretty much there in order to start our whole journey and start writing some amount of code. So go ahead and install this, and I'm sure you'll enjoy the remaining part of the course as well. Thank you. All right. So now we have discussed what is machine learning. We have also discussed what are the components that are required for a machine learning problem. We looked at inputs getting supplied to an algorithm which outputs either a pattern or a prediction. Now this is a sentence that I will keep repeating and keep showing you more in terms of diagrams and pictorial representations, because it becomes more simpler for you to apply if you kind of think in that way. So this is what is machine learning all about. Then we also looked at what are the tools that we can use for machine learning. We particularly discussed installing a Python distribution called Anaconda. And before we go ahead and actually start writing some code and start looking at some example, let's go one level deep into these algorithms that we have been referring to. So I will go ahead and show you what these algorithms are comprised of. However, my main intention of this course is not to go deep into statistics, right? So maybe I'll devote a separate course for it. I will, however, be providing you with some additional reading materials in case you are interested in learning more about actual statistical concepts. All right. So without thinking too much, right, if we just look at this particular diagram, what we see is four main words that stick out, right? One is classification, one is regression, the third one is clustering, and finally we have dimensionality reduction. So this is a very high level way in which all the machine learning algorithms are categorized. So depending upon what problem you're trying to solve, we will choose one or more algorithms that belong to these categories. So you see words like samples greater than 50, then you have category, more data, and so on and so forth, right? So we will keep revisiting this diagram as we move forward. Now, let's take a very simple data set. So your problem statement is use machine learning to predict profits per sale, right? So now we are trying to introduce a little bit more nomenclature into this, right? So we're going to call these inputs as features. Okay. Now let's assume that your input looks something like this. Very, very simple, right? So you have sales, it says $30, $40, $50, $70, and you have the corresponding profit, which is $3, $4, $5, and $7, right? And sales, we are going to, maybe call it as uppercase X and profit as lowercase y. Now don't worry about why I'm calling it uppercase X and lowercase y. We will cover that in detail in the next lecture. Right. So now just imagine that, you have this input and output, and like we have been discussing in all our lectures, we are going to give this to an algorithm, this whole table, and let it study the patterns, right? So that if a similar input comes in the future, it can predict that output, right? So how will this look like? So if you supply this to machine learning, it will output y. Actually, this should be small y. Y is equal to 0.1 times x, right? It's very simple, right? So if you see, 3 is 0.1 multiplied by 30, right? And this is what is machine learning, right? This is what the machine learning algorithm will do. think about it. See, this is how the output looks like, right? 3 is nothing at 0.1 times 30, which is, you know, the profit. Similarly, 4 is 0.1 times 40, and so on and so forth. Right? So since now you have the model, now what I mean by model is this particular equation that you see, this is the machine learning model. So when you actually get a statement like fit a model, right? The model is nothing but y is equal to 0.1 times x, right? What it says is, if you actually give an input in future, any value for x, the y value that you get is your predicted value, right? So let's look at it. So let's assume that if the input was 100, right? If sales input was 100 and no output was given, can you predict the output or can you predict the profit? Well, you can, right? Because you know that it is 0.1 times the sales. So the profit will be $10, right? So this is what we are going to do in this whole course, right? Well, we are going to kind of look at some algorithms which can ultimately give us an equation. And what we're going to do is we're going to supply some inputs to that equation, and that equation is going to spit out an output, right? Now, remember, I have taken a very, very, very simple example, right? We only see one input over here. In the coming lectures, we will see how to take this input in Python and supply to a machine learning algorithm and look at the machine learning model, output, equation, however you want to call it, right? So we'll look at also how to choose an algorithm and how to deal with multiple inputs. You have just one input here, then it's in most of the machine learning problems that you will get multiple inputs, right? And we'll also look at some techniques on how to evaluate if your predictions are indeed correct or not, right? You know, there is plenty of ways in which you can do that. We will study that. We'll take little part of our you know, given set of data, train it, and then, you know, try the same into predictions and see how close it is to, you know, our actual value. So we don't worry too much about it. We'll take that step by step. So having said that, below are some of the commonly used machine learning algorithms. So if you are a starter, this might be a little bit overwhelming. But if you remember, I promised that we've been always dealing with some inputs going to an algorithm. We looked at what are the categorizations of these algorithms. We looked at those 4 categories. And now we're looking at actual algorithms, right? So again, if you're a starter, I would suggest start with some simple example inputs, see what output you get from these algorithms, then decide which algorithm gives you close to the correct prediction. Remember, machine learning is not magic. It's just simple statistics. Your algorithm's correctness and output will highly depend on your inputs. The trick in machine learning is to choose the correct set of inputs and supply to the correct machine learning algorithm, which will give you as close as possible to the correct prediction or the correct result, right? So these are the 2 main you know, categories that we discussed. And supervised is nothing but you supply input and output to the algorithm and let the algorithm study the patterns or, you know, the relationships between the two, so that if a similar input comes in the future, it can actually classify or categorize and predict the output based on what it studied before. So commonly used are your linear regression, logistic regression, we have classification, decision trees, and so on and so forth, right? Then we have a couple of unsupervised algorithms as well. Again, don't worry too much about it. For now, we will take a few examples, take some actual data, and use Python to actually show how to supply that to, say, a KNN algorithm, right? K nearest neighbor algorithm, and, you know, how can we get the output and how can we study the output. Again, we are taking it slowly, adding step by step, so please bear with me here. Again, there are a lot of terms that I introduced in this lecture. I would suggest that you do a reading of these things. And again, as I mentioned, this is not a statistics course and this is not a Python from the scratch course. So you have to do some reading, but I will try to keep it as simple as possible. You know, I try to explain just the minimal things that would be required in order to kind of get your feet wet and, you know, get started. But I would strongly suggest that you just give a brief reading about these things that I have mentioned in the additional reading. that'll at least prepare you well for the next lecture. Thank you so much. All right. So welcome back. And what we are going to do in this particular video is kind of do a very quick overview of the tools that we will be using to write our first line of code. Right, so we will look at Anaconda distribution of Python and the various tools that we installed in the previous lectures. So let me go ahead and fire up Anaconda, and this is called Anaconda Navigator, and as soon as you start the tool you will see a couple of options. Right, so this is how it looks like. So you see that by default it has a couple of things on the first home screen, right? And if you see these buttons, there is either the launch option or install option. And if you have install option in Jupyter, go ahead and definitely click on it and install Jupyter Notebook, because that is basically the primary tool that we will be using to write code. Okay. Now, this is kind of the navigator starting point, right? This is the place from where you start launching tools. And before we go further into it, I just wanted to walk you through some of the options available, right? So learning is, it has a rich set of documentation, different reference guides, tutorials, NumPy documentation, and so on and so forth. And you will find this to be extremely useful when we start discussing some concepts in data science and machine learning. So definitely have a look at that and read a few things. There is also a good community where you can participate, and these are all forums, and definitely have a look at that as well. All right. So what we're going to do is right now, and we'll cover some of them in the oncoming lectures, but we're going to particularly focus on Jupyter. So let me go ahead and launch that. And once I do that, you will see that this opens up in your web browser. So this is a web browser based tool, right? So what I'm going to do is, this is kind of just showing you, your default path. You can definitely go to the navigator and change your default path. I'm going to create a folder, and I'll just call that as got created somewhere here. Let's see. Hopefully, okay, here, this one. So I'll go ahead and just rename this, and I'll call this as Python programs. Okay, so we have a folder ready, and what I'm going to do over here is I'm going to go into that folder and I'm going to create a new Python 3 notebook. And as soon as I do that, it kind of launches this new tab, right? So let me just rename this to my first hello world program, something like this. All right, so we have launched this. It gets launched in web browser. Now the cool thing is that all your interactions are going to be through this web browser, and that's a cool thing that I like, right? So and let me show you a couple of things, a couple of these options and stuff like that. So let's go ahead and first type our first line of code. I'm going to say print hello world. And what I'm going to do is, if I just press the enter key, it will go to the new line. But what I'm going to do is I'm going to press Control and enter, and it will actually execute that line of code and output hello world, right? So definitely practice a few things in Python, because we will be going a little bit faster. I'll definitely explain the code and stuff like that, but this is how a typical Python program and the Jupyter workbook looks like, right? And now there are a couple of other options available here. And the first thing I wanted to tell you is about shortcuts, right? So if you press the H key, it actually opens up all the Jupyter shortcuts, right? So for instance, I could just say, let's say this one, insert cell below, and then it kind of inserts another cell, and I'm going to call this as, say, hello world 2, and I could just say control and enter, and it will output that. As against that, I could just press the H key, and if you see here, the letter B is the insert cell below, right? And in order to do that, there are two ways, right? So if you see this particular cell becomes green, that means it is active right now and you're able to type. So basically, if you type B, it'll actually go ahead and show the letter B, and it will not actually insert a new cell. So what you should do is you should press the escape key, make it blue, and now type B, and then it goes ahead and adds a new row or adds a new cell. And to navigate between cells is pretty easy. You could just use your up and down arrow keys, go to the cell, press enter, and then start modifying it, right? So this is kind of how we will be using it. Now, one cool thing about this particular notebook is that it also you can type in some Python code, and also you can type in some markup, right? So now what I mean by that is, let's do something like this. Oops, enter my first Python program, right? And what I'm going to do is I'm going to change this to Markdown. Now if I press Control and enter, it will actually show this as a normal HTML or a markup language. So let me press enter and make some modifications, right? So I could just put this as bold, oops, and things like that. So a lot of stuff you can do. It's a combination of, you can write your code as well as your programs, and pretty much if you think about it, I have been using Google Docs to kind of store my presentations or so-called notes. I could just do it lecture 1 and then there's some code, lecture 2 some code, and things like that as well, because all I have to do is just put some markup over here, and then I can kind of write my code as well. So I can continue writing my code. Press the button key, B, and then I could just continue with my code, right? So some shortcuts here that we talked about. Definitely play around with this. This is very, very high level at this point, but I'll try to be more verbal when I start typing some code. Definitely for the next lecture, I would say read upon what is the import statements, what are modules, what are functions, how do you import a module, and things like that. Again, we'll try to keep it simple for now before introducing more complexity, but definitely read more about Python or take a brief Python course so that these things don't come in your way of learning machine learning, right? Because that is the whole purpose of this course. We're going to walk through some algorithms and stuff like that, so we won't be too much focusing on just the Python aspect. Having said that, I think we are ready to start taking some data, applying to an algorithm, watching the output, the same things that we talked about in the previous few lectures. So in the next lecture, we are going to exactly do that. So see you in the next lecture. Bye. Hey guys, welcome back. So I hope you are liking it so far. We're just adding more things incrementally. I didn't want to really start typing some code right from lecture 1. The concept is to see if we can slowly keep adding more and more stuff into it, and slowly we can introduce the concept of machine learning. All right, so now we know about algorithms, at its types, and its categorization, and things like that. But one of the things which kind of I keep repeating is this diagram, right? You have the input data and then you supply it to a machine learning algorithm, and that will actually give you patterns, predictions. Now I will keep repeating this as we'll use the same approach and keep adding more and more stuff to this. All right, so for us to start with our first machine learning implementation, right, we need some data set, right? And generally data set will be depending upon your business problem and your domain knowledge, you will gather the data set. But let's keep things very simple for now. Let's kind of take a data set which is readily available, publicly available, and we'll apply some algorithms to it, right? So in that way, you at least know how things work, and then we can start taking some examples where we kind of take some inputs, modify it, and so on and so forth, right? So one of the data sets that's like commonly available, and any machine learning book that you take, you might find a reference to this. It's called as the IRIS data set, right? Now, basically this is nothing but 50 rows of data, right? And iris, basically there are 3 species of iris that's basically mentioned in this particular data set, right? So what they have done is they have taken some measurements, basically the length and width of the sepals and petals, and then depending upon those measurements, they basically say what type of iris it is, right? What is the species? Is it a iris setosa, virginica, or versicolor, right? So if I actually, there's a Wikipedia link, let me open that for you, and it kind of explains some history behind it, but the data looks something like this, right? So basically, as I said, it has about 50 rows in it, and it has more than 50 rows in it, but anyways, so these are the different species, and what we see in this particular data is the sepal length and sepal width, and petal length and petal width, right? And depending upon those measurements, the species is identified. So the concept is, as we have kind of discussed before, is if we supply this data to a machine learning algorithm, and in future if we get a particular iris sample, can we kind of looking at the pattern of its length, width, and petal length, width, can we kind of identify what type of iris species is it? So that's the whole idea behind it, right? So definitely read through this, some rich data set over here, and they'll give you some information on the history as well. All right, so I guess it should have, I believe, 150. So basically, I think it's 50 samples of each of those species, right? So yes, so it's not total 50, it's 50 per sample. Okay, all right. So now let's see how can we download this data, right? So let me go ahead and just Google this IRIS data set download, and let's see if there is something publicly available. All right, let's take this, right? So this has this publicly available data, and one thing is, if you kind of use this website, there is tons and tons of data set that you can kind of use it in practicing your machine learning algorithms as well. All right, so let's go ahead and see if we can kind of download this data. So data folder, yeah, we have iris data, and this looks like, let me actually just copy the URL, and let me launch a notebook. All right, so we are going to probably open the same notebook that we created yesterday, that we practiced. All right, so what I'm going to do over here is to add a couple of cells, and first thing is that we can look at the data, and the way we can look at this is, if you remember, I mentioned that just read a little bit about modules, functions, and stuff like that. So I'm going to basically write some code over here to visualize the data, right? So data is coming from that particular download URL link that I have copied to my clipboard. Just set copy link address, and the way we are going to do that is we're going to say from ipython.display I want to import HTML, and I'll say HTML followed by the URL that I just copied. And what I'm going to do is I'm going to press Control and Enter, and it's kind of going to download the data from that URL. and it's going to display it in line. Now this is where I said that it's really powerful, right? With minimal amount of code, you can actually directly download something from a URL and start to work with that data. And again, if you want to like format it a little bit, that's also totally fine, and it goes the same way. You don't need to write this again, but just for simplicity, display import HTML, and I'm going to say HTML, and then you can just format it as a normal HTML. So I can just say something like iframe, the source should be my URL, right? And that's it. Put in an iframe. Hopefully this should work. All right, so it kind of formatted that. All right, so we now have kind of played around with it, how to look at the data, but let's take a little bit of a deep dive into the data as such, right? The reason being that we really need to understand certain terminologies that we will be using throughout. So this is how our data is looking like, right? And in future, what we'll do is we will call the number of rows here as observations, right? As the English word observations, you have, each row is an observation. So these rows are called observations. The columns, the input that we have been referring to so far, we'll be calling it as features, right? And the target is these values, the IDEs PC values. So three terms which we'll be using: your observations, number of rows, your inputs, that is called features, and your predictions or outputs, that we'll call as targets, right? These are the common input terminologies we will be using throughout. All right, so if you kind of relate it to our input sample, our iris data sample, your input data, that is sepal length, sepal width, petal length, and petal width, which you will be supplying to an algorithm, these are called feature names, right? And the output data, these are called as target names. Okay, so just keep in mind about those two things. All right, so moving on. So now you need to remember two main things which will be used throughout this course, right? Number one is you need to pass your inputs and outputs as different objects, and Python calls this as numpy array. So don't worry too much about it. We will look at an example just after this. Numpy is nothing but an inbuilt packaging system. Just imagine it as an array, but it's optimized for faster processing, right? And the second thing is all your inputs and outputs that you give it to an algorithm should be numerical, right? But that's tricky because these things are numerical, but what about the outputs or targets? They are not numerical, right? So what we can do is we can simply assign some numbers to it, right? We can call setosa as zeros, versicolors as maybe 1, and so on. And the good thing is that Python will actually do this for you. And we'll look at it, just in a short while. We'll look at, all those things. All right. So having said all of those things, I would just like you to take a small pause and go through these reading materials, right? Because these are the concepts that we will be using. We'll be using NumPy, and we'll be using the two things that we discussed, right? Your inputs and outputs in a NumPy array, and then making sure that the inputs and outputs are converted to numerical form, and then supplying it to an algorithm. That's precisely what we'll see. So if you see the diagram, I have changed it a little bit. Now I want you to just take a guess on why we used an uppercase X and a lowercase y, and submit your answers in the forum. In the next lecture, we'll precisely use that and directly start coding. Thank you. Hey folks, welcome back. In the previous few lectures, we saw how to read data in Python. We also saw the concept of fitting a model or passing input to an algorithm mainly comprises of two steps. Right? First, you need to pass your input and output. as different objects, and we will be using the numpy arrays, and I've given some reading materials also that will help you understand this concept. And secondly, you need to make sure that your inputs and outputs are numerical. In this particular lecture, we will be looking at some code. All right, so let me go ahead and just open up the Jupyter notebook that we were working with. And what I'm going to do is we're going to work with the IRIS dataset, the same dataset that we kind of talked about in the previous few lectures. All right, I pressed the button B to go to a new cell. And again, if you press the button H, it will show you all the shortcuts that you can use. And I just inserted a new cell below by pressing the button B. All right, I'll close this and then I'm going to type in some code. Now, IRIS data set, right? We looked at the data from this particular website. Now, IRIS data set is like the hello world of machine learning, right? And hence, Scikit actually gives you this particular data set inbuilt, and so we can just directly use them. We don't need to go ahead and download it from an URL and stuff like that. But I just wanted to show you that in case you have a CSV file, how do you go about loading that data and working with it. So for this particular tutorial, we'll keep it very simple. So the way you can do that is, first of all, you need to go ahead and use the concept of modules and functions that we talked about. So in the sklearn dot datasets, there is actually an inbuilt IRIS dataset. So I'm going to use the load IRIS method. And next, what I'm going to do is I'm going to use the load IRIS to get all the data and store it in the IRIS object. Okay, so this is right now stored there. And next, what I'm going to do is, of course, let me show you a few things, right? So if you look at the type of this object that I just created, if I press Control and Enter, it's actually something called as bunch. Now, what exactly is bunch, right? You must have been probably heard this for the first time, because normal data types that you hear are objects or integers or strings and stuff like that. Here you see something called as bunch. So what are they? So if we go back to our particular notes, bunch is nothing but it's kind of a special data type that Scikit provides in order to store your data set. So in the bunch data type, there are many attributes. So if we kind of visualize that with the data that we have, the data attribute will basically have the entire data, right? Target will have all the target names or your outputs. So data is all your input values, target is all your output values. As we discussed, these column headers are called as features, right? So if you just use the feature names, it will actually output what are the column names of your input data. And similarly, if you basically look at the target name, it will actually specify the target's names as well. We can quickly look at that in the code as well, but I just wanted to kind of show you how this all relates. So let's look at the data, target, feature names, and target names as well. So how do we do that? So let me go ahead and insert a new cell by pressing the button B. And now what I'm going to do is I am going to let me just print out a few things. So I'm going to print IRIS dot feature names, right? So what should it give me? It should basically, these are all the features, these are all the feature names, right? Sepal length, sepal width, and so on and so forth. So if I press Control and Enter, it will basically give me that information, right? So this is basically our feature names. All right, so let me press the button B and then print out a few, print out a few more things. Then we talked about target name. So how does that look like? And again, these are all inbuilt keywords. So target names, if I press Control Enter, it's going to show me the value. So these are all the target names, the prediction values, right? Or output values. All right. So let's try something else. Let's try, I always do this mistake, print I'll do iris.target. And it kind of gives me a vector over here, right, of zeros and ones. And if you remember, the two main rules, oops, loads, okay, something happened. So the two main rules that we discussed is basically your inputs and outputs should be numerical. Your outputs are not numerical here, and what it has done is it has assigned certain integer values for the output values. Like for example, Setosa is assigned number 0, versicolor may be assigned number 1, and so on and so forth, right? So if we kind of look at this particular thing, you see that it is zeros and ones. So it's kind of ready to supply it to our algorithm as well, right? And then what did we forget? Let's go ahead and look at our data as well. So print iris dot data, control enter, and it will kind of show you that particular matrix, right? So two important things you should note over here. I called this as a vector, I called this as a matrix, right? Now naturally you see that both of them are numerical, and how do we really identify whether both of them are numpy arrays, right? Our first rule was that your input and output should be, first of all, different objects that we can definitely put it, place it as different objects, but they should be numpy arrays. And then the second thing is input and output should be numerical when you supply it to an algorithm. Now, definitely they are numerical, but I need to make sure they are, of numpy arrays as well. So I'm going to press the button B, enter, and then the way that you can just test that is you can just say, show me the type of iris.data, and it's a numpy, right? Similarly, let me go ahead and do for the other thing, right? It's iris.target, and that is a numpy array. So it looks like the initial portion, the input is getting ready, right? Now both the conditions are satisfied. The initial conditions are getting ready, and then before we supply it to the algorithm, I also told that both of them, input and output, should be different objects of numpy arrays. They are numpy arrays for sure, we just found out. Let's just put them as different objects, right? So I'm going to store the data portion, that is this portion, in capital letter X, right? Because it's a matrix. And I'm going to store all these values, the zeros and ones which we just looked at, those are vectors. I'm going to store it in lowercase y, right? So let me go ahead to in my Python program, and then let me actually the new cell. And what I'm going to do is I'm going to store iris.data in capital X, and I'm going to store iris.target in capital Y, and press Control Enter, and it has stored them, right? So all of our conditions are satisfied. So the first part of it is satisfied, right? We have capital X, capital Y, both are numerical, different objects, they are in numpy arrays. Now the first portion is done. Next is basically we need to supply this to an algorithm. That is what we call it as fitting this data into an algorithm. And in this case, we are going to be using the KNN algorithm. Now, before we proceed further, let me spend about a few minutes actually talking to you what is the KNN algorithm. Now, the goal of this is definitely not going in too much detail of how this relates to in statistics, what are the different equations and stuff like that. But at a high level, I just wanted to tell you what this KNN algorithm does. Now, please note that we're going pretty slow over here, right? We're typing a few lines of code and then talking about some theoretical aspects and stuff. But I promise we'll start picking up some pace. Because any algorithm that you choose here or any input that you choose here has to follow these same steps, right? It has to be two different objects, it has to be numerical, it has to be numpy arrays, and then there is a couple of things you need to know in an algorithm. Once you get that framework very solid in your mind, it doesn't really matter what your inputs are, what your algorithms are. The basic framework remains the same. It's just fine-tuning these two components, right? So that is why I'm going a bit slow. All right. So the next thing is, before we pass on, let's look at what is KNN algorithm. Now, if we go to a Wikipedia link, and I strongly suggest that you read about this, in depth, but let me give you a high level overview. So Let's look at some example, if there is an example here. All right, let's look at these numbers, right? These figures. So if you look at this basically has some points in it, right? It's very simple concept. It has some points in it, and what are these points is, just imagine this is your y-axis, this is your x-axis, right? And it basically has an x coordinate and y coordinate, and according to what values it is been plotted in this graph. Let's assume that this red point has an x coordinate of 2 and the y coordinate of 3. So this is, and then the output is say red, right? So basically they have gone ahead and plotted these points and they have colored those points. So this will be something like maybe 5, 2 and blue, right? So they have kind of plotted all these points over here. Now, if you closely look at this, very closely look at this, you can actually draw some sort of a boundary here, right? Imaginary, just imagine that there is a boundary over here and you color that boundary as red. All this is red portion. It's like marking your territory, right? You can actually mark a small territory here for green. You can mark a territory here, something like this, for blue, right? Now, in essence of what I'm trying to say over here is, let's assume that you get a point in future which says it's say 6, 5. It will be somewhere over here, right? 6, 5 will lie somewhere over here. Now, looking at this territory, can you guess what is the what would be the color of that point? Whether it will be blue, red, green, or whatever it is. Since we have said that this anything that lies in this particular region is blue, the chances are that it is very likely that that point is blue. Hence, we predict that that particular point that you gave me as an input, the prediction is blue, right? So that is the whole goal of this. So we pick up different values for k and we start fine tuning these boundaries, right? So if I go to my next image, this is how it looks like. This is what I talked about, right? So you have actually drawn a little boundary over here and marked the whole background as red. Similarly for blue. So next, if a point comes over here, you know that it's basically lying in the green region, hence the point will be green, right? So this is basically called as the k nearest neighbors algorithm. Now I have very much oversimplified this, but definitely you will need to read about this, understand a little bit about the Euclidean space, the distance between 2 points, the distance between neighbors and stuff. But once you understand this whole story which I told you, you will be able to appreciate that whole concept of distances and how this whole algorithm works and so on and so forth. So hope you get some insights on that. Please read the whole thing, and in the next lecture what we are going to do is we're going to take this a little bit further. Now since we know that what KNN algorithm is, we are going to take the x and y that we just created and then pass it on to a KNN algorithm and study the patterns, right? How the patterns are occurring, right? Or how the whole model fits in. All right, so hope you enjoyed this particular lecture. See you in the next one. Bye. Hey guys, welcome back. So let's go ahead and continue our journey in which we start building our machine learning model and try fitting our model. So what we did in the last lecture is we in detail saw how to define your capital X and small y, the matrix and the vector, right? So this is nothing but your input phase, right? So you basically gave your inputs and your outputs to the algorithm. Now in this lecture, we are going to precisely look at that particular portion, that the second phase of it, like how do you supply it to an algorithm, which we basically called as fitting the model, right? So essentially, there is again a simple framework that you need to follow. There are 3 steps to it, right? When you actually start writing some code, one is you have to import the class, second one is you have to instantiate it, and third is what we call as fitting the model. So don't worry too much. In about 2 minutes, I'll show you how to do that. And these are the 3 steps which we will pretty much require in any algorithm that you're trying to use. So in this, we'll be starting with the KNN or the k nearest neighbor algorithm. In the previous lecture, we talked a little bit about what that whole algorithm is about, right? How do you draw the boundaries and the neighbors and stuff like that. Now again, just to reiterate, that was a very, very oversimplified way of telling you what KNN does. Definitely, it will require a more statistical lecture
to go in very much detail about what that algorithm does and so on and so forth. And what I probably was thinking is that's not a perfect fit for this particular course, because here we are just trying to get ourselves acquainted with the concept of data science, what are the components involved and so on and so forth. All right, so the way that I generally start off is, before I implement any algorithm, I would just go to the Scikit-Learn website and look at some documentation and sample code. So this is how it looks like, right? You just type in the KNN search and it will give you a bunch of stuff here, right? So the class is sklearn.neighbors, and you use the neighbors classifier and you pass in a bunch of things in it, and we'll see more into that. All right, so there is good explanation on what each of those parameters do. And if we don't supply those parameters, it's going to actually use the default values, right? And here is some sample code to get started with. Now, this is what I generally use, to just look at how they are importing the classes, modules, and so on and so forth, and how they are fitting in the models. But don't worry about it. I'll show you from scratch all these things. But I just wanted to let you know that this is how you should be starting when you choose another algorithm. All right, so let's go ahead and start writing some code. So this is the portion we are going to do now. All right, so I have opened my Jupyter workbook, and in the last lecture we defined capital X and small y, right? And this we are going to go ahead and fit the model. All right, so if you remember, initially what we said was that first is we have to import the class, right? And looking at the documentation, we found that to import the class, we need to use the kneighbors classifier, right? So I'm going to use sklearn dot neighbors, and I'm going to import the kneighbors classifier. And how did I get this? I just looked at this particular documentation, kneighbors classifier, right? So I need to do this. So I need to import that first, and let me go ahead and press Control and Enter, and it has imported that. And next what I'm going to do is I am going to use the KNN, actually I need to first instantiate kneighbors classifier, right? So I'm going to use kneighbors classifier, and I'm going to just pass in one default value over here, the number of neighbors equal to 1, and I'm going to store this in KNN object. All right, so just keeping it very simple here, I passed in n underscore neighbors is equal to 1, and if you look at the documentation, there are actually lots and lots of parameters that you can pass, right? And all the parameters are listed here. And what we did was that we just passed one of them, right? N underscore neighbors. And if you don't pass all of them, all it'll do is it'll use the default values. Now, to keep this example very simple, let it take the default values, right? We'll just use the number of neighbors equal to 1 and fit the model and see how it predicts, right? The goal is again not to go into too much detail of the algorithm here, but just to look at some working code. So I'll press Control and Enter, and it gives me an error because I might have misspelled something. Okay, so that worked out fine. And now what I'm going to do is I'm just going to print this KNN object, Control Enter, and if you see that it has actually set all the default values except for n underscore neighbors equal to 1, because that is what we passed in. So these are all the values that you can set when you are instantiating the class, right? And any algorithm that you take, this it'll be the same principle to be followed. There'll be a couple of default values that you can set, and then you can use it going forward. All right, I'm going to press the button B for a new cell. So now we have the instantiated class, right? Now we can go ahead and fit the model. The way we can do that is we use the KNN object that we just created, and then just call the fit method and pass in two things: our input matrix, capital X, and our output vector, small letter y or lowercase y. Once we do that, it will actually complete that next fitting the model step, right? So this is the step I'm talking about. So it will actually take an X and Y and put it into the algorithm. That is basically called as fitting the model. All right, so that is done. Now, how do I know that this all worked fine, and how do I know whether it's predicting something? And the answer is very simple. Let's try inputting some values and see whether it can predict something, right? So let's go ahead and do something. So if I use the KNN dot, and there is something called as a predict method. These are all inbuilt methods. Let me pass on some values to it. So I have some values here, 2, 4, 3, 1, right? And this is again similar to our earlier table, right? So we used to pass in values like this: 5.1, 3.5, 1.4, 0.2. These are the four input values or features. So I'm going to just use that. So I'm going to pass another 4 random values, 2, 4, 3, 1, and see what it predicts. So the way you can do is just pass in as one matrix, 2, 4, 3, 1. I can kind of do this, and whatever is the results, I can kind of store it in, say, something. You can name it anything. I'm just calling it prediction. And the value is now stored in the prediction variable that I just created. Now I'm going to just go ahead and you can actually even look at the type of prediction. So it's an ND array, so it returned an array. So when I call the predict method, it returned an array over here. And now what I'm going to do is I'm going to just print it out. Okay. So it basically returned an array, and the value is 0. Now what is 0, right? If you remember our fundamental principle of of this algorithm, we said that it should be numerical and has separate objects and numpy arrays, right? So your output is also numerical. Now what is that 0? That is what we said, that when this particular table was created, we said that I dot setosa may be 0, I dot something else may be 1, and so on and so forth, right? So those are basically the target names. Now which target name corresponds to 0 is what we have to find out now. And to find that out is pretty simple, right? What I'm going to do is I'm going to just print out the target names. And if you remember, we had used target underscore names to get that out. And you see 0 is setosa, 1 would be versicolor, and 2 would be virginica, right? This is how the the array would be numbered. So in short, we fitted the model and we tried for inputs 2, 4, 3, 1, right? And the output was setosa. So let's make a note of it. So the output was 0 or setosa. So now what did we do is we used the KNN algorithm. We used n is equal to 1 in our default values. We passed in, we fit the model first of all, so that it learned the existing inputs and outputs that we gave. And then based on what it learned, we said that, okay, now depending upon what you learned, can you predict what happens when the inputs are 2, 4, 3, 1? And it predicted that it is setosa, right? So congratulations, you have written your first very raw, very primitive program, right? So let's take this a step further, right? So let's say that I want to predict. So now we predicted only one input, right? One row of data. What if we need to do two? And it's pretty simple. So the way that you can do it is again the same thing. I'm going to say store my results in prediction array, and I'm going to use the same k.predict, and my first would be 2 4 3 1, and I can just keep giving more and more inputs, 4 6 5 3, right? So one line of data with 2 4 3 1, second line with 4 6 5 3. These are the features, and let's see if it can predict something. And let's see. So it's 0 and 2. So that means it's setosa and versicolor. So when you give this input, the output, predicted output is 0 or setosa. And for this one, 4653, it is versicolor, or sorry, it is virginica or 2. Right? So let's make a note of it. So when I have 2, this remained the same. And this became virginica. Right, so I hope you're getting it. So I can kind of pass a complete matrix itself, like and then it can actually return a complete vector of all the predictions in one shot, right? So as and when you need to have more and more inputted data to be predicted, you can use different forms and techniques. But right now I'm just using one or two examples. In like later videos, we'll see how to kind of pass in 50 lines of inputs or 100 lines of inputs as a complete matrix, and then get the output. All right, so before we go any more further, I would like to also tell you that we used knn equal to 1, right? So what will happen if I have to use knn equal to 5, right? So knn equal to 5, what will happen? We know the values of 1, so let us just copy that. And let's see if the value of, if n has changed, does the predictions change, right? Let's see. So for knn equal to 5, I'm just going to use another object. I'll call this as knn5, and then I'm going to use the same thing, k neighbors classifier. And now in default value, I'm going to just pass in n underscore neighbors equal to 5. If you see above, what we did is that we used the same thing from Scikitlearn neighbors. Oh, by the way, you have already imported the k neighbors classifier, so you don't have to import it again. But we used knn object, and then we just use n underscore neighbors for k neighbors classifier. Now we are just using another one, knn5. You can call this anything you want, but now I'm basically instantiating with n equal to 5, the number of neighbors equal to 5, right? So once that is done, I am going to use the same thing, right? I'm going to use knn5 dot fit, and I'm going to pass in my entire capital X, entire matrix, and my output, and let it study the interactions between both of them. So it did that. And next what I'm going to do is I am going to just create a new object. Let's call this prediction 5, and I'm going to use knn5 dot predict, and I'll use the same inputs that I passed in for my previous example, right? But my previous example was based for n equal to 1. Now here it is n equal to 5. Let's see if that makes a difference. And let me go ahead and print prediction 5. So now it is 0 and 1. Earlier it was 0 and 2, right? So now it is saying it is setosa and versicolor. So let's make a note. All right. So, like, why is this happening, right? Um, for n is equal to 1, we got some other results. For n is equal to 5, we got some other results. In the coming lectures, we will definitely see what is more correct. Right now, we don't know what is more correct, right? And let's keep it that way for now, right? Let's just, our intention is to, get some practice over fitting particular algorithms, models and stuff like that. And in the coming lectures, our goal would be to tune that, right? Given n is equal to 1, n is equal to 5, n is equal to 8, 13, or whatever numbers, or even another algorithms, right? Here we are just using KNN, right? So we use, say, 10 algorithms with different input variables. We will get different results. So that is where the fine tuning will come, and kind of shortlisting out of those 30 things that we saw, which is more closest to the correct answer, right? So we have reached here. We have seen n is equal to 1, two inputs and 2 predictions. N is equal to 2. N is equal to 5 and another 2 predictions for the same set of inputs. Now, what I want you guys to do is, can you repeat this for n is equal to 8 and see what results you are getting, right? So in further readings, I have given you something on k-neighbors classifier, the documentation that I used. But more importantly, can you run this for n is equal to 1, 2, 3, 4, 5, 6 up till 30 and build a table? And it's actually very simple. If you see, this whole thing took me 3 lines of code. So what I want you guys to do is learn something or read about Python looping construct. How can you run this in a loop, right? And I have provided a small link which will help you get there. But basically, try doing that. And I've given you answers for n is equal to 8 over here. And it's again the same thing, right? I just use this same example, but the default value while instantiating, I just gave it as n is equal to 8, like n underscore neighbors equal to 8, and ran the whole stuff again. And this is the answer that I got. But try it out from 1 to 30 in a loop, in an automated loop, and see if you are able to get that. And if you are able to get that, please post it in the forum. It will be really a nice achievement, I would say, if you are an absolute starter. And the next thing is, definitely take one more algorithm. Take logistic regression. We used k nearest neighbor. Use logistic regression and try to run the same algorithm, a same set of inputs, but for different algorithm called logistic regression, right? And try to take a stab at that. I'll show you how to do that as well. But if you just type in logistic regression, you will get some documentation around it. And I showed you how I do it. This is how you can import the class, right? And this is how you pass in the default values. And try to read a little bit about that, and see how much it varies from KNN in terms of what predictions it is making. So we are getting more and more into it. Hope you're liking it. In the next lecture, we'll look at a few more things, a new algorithm, and see what type of predictions it gives us. Thank you, and see you in the next lecture.
All right, welcome back. So we are in chapter number 9 right now. And, if we were to give a quick rewind of what we did so far, we basically learned how to calculate the capital X or the matrix X and the vector Y. That is basically your first part of preparing your inputs. And then we passed it to an algorithm, and we used the k nearest neighbor algorithm, and we used different values of k, right? Different parameters for k in the k nearest neighbor or KNN algorithm itself. Now what we are going to do over here is we are going to repeat the same thing in this lecture, but we are going to use a different algorithm. In this, we are going to use logistic regression. And the idea behind doing that is to give you an idea of, how do we kind of test with different algorithms or different parameters of the same algorithm. In the previous lecture, we exactly saw that, right? We just used one algorithm, KNN or the k nearest neighbor, but we use different parameters. K is equal to 1, k is equal to 5, k is equal to 8, and so on and so forth. So you find that there are variances in that. In this, we are going to use a different algorithm altogether. So you get a
practice of both of them. So if we go back to our lecture number 1 or 2 where we discussed this is still a classification problem. Logistic regression, is an algorithm for classification problem. Now, again, in the further reading section, I have given you a very good YouTube link of one of the professors who explain logistic regression. So I would encourage you to kind of watch that if you're interested in knowing in depth about that algorithm. But in general, classification algorithms are nothing but in which the outputs are finite, right? So your input could be an email and your outputs could be whether it is spam or not spam, right? Something like that. So a finite set of outputs. So this is one such algorithm which is used to solve a classification problem. So this is the portion of it. So we use the k nearest neighbor. Now we are going to try one more algorithm. All right, so again, let's just revisit our thing that we have been saying in every lecture. The logic remains the same irrespective of what algorithm you use, right? You calculate the capital X and small y. You make sure that the two fundamental criteria are fulfilled, like both of them are different objects, they are numpy arrays, and both of them are numerical, right? So we saw how to do that. And the next is basically we use an algorithm where we import the relevant class, instantiate it and fit the model and let it study the inputs and outputs, and then it can predict based on those relationships. So before we go into logistic regression, let me just quickly open up the Scikit-learn documentation. So this is how I generally start, right? So if I were to kind of have a set of inputs and if I want to try it into a couple of algorithms, I generally start with this. So this is a nice place for you to kind of know a little bit of code and what are the default parameters and so on and so forth. So this is the class and these are all the parameters. Again, you can read in detail about the parameters, what it does and what are the default values if you don't supply a parameter in your whole code, right? So this is how it works. So let us go ahead to our notebook and then kind of run logistic regression. So I have made a note of what all algorithms we have run so far. So as I said, we ran it for 1, 5 and 8 and we got these values for these inputs. Let's fit a model, train and fit a model for logistic regression and pass in these two same inputs and see what is the prediction we get. All right, so I'll press the letter B, enter, and now what was the class? It was Scikitlearn dot linear underscore model, right? And your class was logistic regression. Okay, let's go back to our notebook and then let's do this. Scikitlearn dot linear, and it was model, and I'm going to import logistic regression, right? And I'm going to just the next step is definitely instantiate the class. So logistic regression, and I'll just store it in an object called logistic reg, something like this. You can call it anything you want. And the next step is fit the model. So you basically use logistic rig dot fit, and we have our X and Y that we created. Now if you're actually if you have closed your notebook and you're opening it again, you might get an error right now because the code that you have on the top to basically store your capital X and Y, you might have to just recompile them. So if you get an error, just make sure you go to each cell and then press Control Enter to just execute them, so that it knows what is X and what is Y. In our case, it should know because I've been using the same notebook and I haven't closed the notebook. So it has fit the model, right? It has fit the logistic model. And now what we are going to do is we are going to use the predict method and pass in the two input parameters. So logistic, let's do this, logistic rig dot predict, and we had our two inputs, right? So we'll use these two same inputs. and it should return an array. So we'll just call it as prediction underscore logistic regression, LR. And once it does that, let's just go ahead and print the prediction underscore LR. So it is 2. The prediction for the first input is 2, second input is 2. Now if you remember, 2 I believe was versicolor, but we can just quickly check that as well. And the way we do it is again same, the iris data set, and there's an attribute called target underscore names. It's Virginica, I'm sorry. So 2 is Virginica. So let's make a note of that. So this came out to be 2, and the second one also came out to be 2. Right now, if you think about it, for different algorithms or for different parameters inside the same algorithm, the results can vary. So how do we really choose which parameter or which algorithm is the right algorithm to choose for, right? And the answer is we don't know. We don't know because we have no idea about what the actual answer of 2431 or 4653 is. We don't know it. We just randomly took some numbers over here, right? But what if we actually had some input in which we actually know the actual output also, so that we can kind of compare it with what these predictions are made. It's like quizzing the algorithm, right? And if we think about it a little bit more and deeper, we actually have that data, right? We have this rich set of input data that we use to train the algorithm, right? So once it is trained, why don't we just quiz the algorithm? Let's just pass the same values, 5.1, 3.5, 1.4, 0.2, and see whether it predicts setosa. And if it does, we know that that's the correct answer, right? If it doesn't, we know that that's not the correct answer. So the algorithm is not providing a good answer, right? So that's kind of a good way. So let's go ahead and do that. So I'm going to open up my so by the way, I've just created a small table with, I've chosen this first row and the last row, 6.3 and versicolor, right? And we will see what predictions these give for n is equal to 1, n is equal to 5, n is equal to 8, and logistic regression. We don't need to do everything. We'll just take 1 or 2 samples, but you'll get the you get the idea about that. So I have the code over here. It's the same thing which we kind of used in our previous lectures. So just for the interest of time, I just copied it. So we're just calling the predict method. It is same as what we did here, but instead of some random inputs, we are giving inputs for whose outputs we actually know, right? In the first case it is setosa, and the second case it is versicolor. We know the actual answers for this. So let's go ahead and run this. We say that it has actually correctly predicted 0, 1, 0, 1, 0, 1 in all the 3 algorithms, right? So this is one of the ways of doing it, right? Now this was a very simple example we just had like 150 rows of data over here, and we passed in some values to it. Now there has to be a more systematic way, right? What if you have a set of data, you calculated your capital X and small y, and now you want to try it for 10 algorithms? Would you keep doing this? Would you keep manually doing what I did right now? Or let's assume that each algorithm has 4 different parameter combinations that you can use. Just like in KNN, we used k is equal to 1, 5, 8, and I could even give 30 and stuff like that. So imagine that. So you have to actually try this for the same set of inputs like 50 times. And that's going to be time consuming, right? Because you're not going when you're at a job and you're solving a problem, you're not going to have inputs which is just very simple 150 lines of input. You'll have inputs which is like millions of rows. So when you actually give it for training and stuff like that, each time you run something like this, right, like dot fit and all, here it took like a second. Depending upon your inputs, it could take an hour or 2 hours, right? Now imagine if you have to do that 50 times, it's going to be really, really time consuming. And how do you choose? So fortunately, there are some techniques to kind of choose optimal parameter or optimal algorithm that works with your set of inputs. Now Python and Scikit-learn actually provides a lot of inbuilt mechanisms to do that, in which it can tell you that, hey, if you use knn with k is equal to with n is equal to 5, your accuracy is 95%. But if it's n is equal to 8, the accuracy is 97%. But if you use logistic regression, the accuracy is 99%. And it can kind of give you a nice little table with all that details. And then you can just look at it and say, oh wow, I think I should go with this algorithm and retrain my model, because this is giving me the closest accuracy that I need. So in the coming lectures, we will be precisely doing all those things, right? We will be looking through some of the mechanisms in which we can choose these different parameters or algorithms. Now, the whole idea of all these 9 lectures was to get to a point where you're comfortable creating your inputs, capital X, small y, and then choosing, and not even choosing, just supplying it to an algorithm and making some predictions, right? So remember that diagram which I always show in each lecture, that is going to be the same. Now we are going into the portion where we start fine-tuning the parameters of an algorithm, or fine-tuning the choice of algorithm, right? Again, we'll just touch all the simple basics of it, and then go on, we'll add more and more complex concepts as we go further in the lectures. So far, I hope you're liking all the lectures. If you do like, please leave me a comment, or in the forum, on what you feel, what are the things that you're learning so far, what are the things you'd like to see, or is it going too fast, or is it at a comfortable pace, and I'd really love to hear more on that. The whole goal of this exercise was that I've taken a very complex subject, and I've tried to assume that people are starting from absolute scratch, and then I've tried to remove all the complexity and make it as simple as possible, and add a little bit of complexity in each lecture, right? So that it's not too overwhelming. So I would love to hear your feedback on how things are going for you so far. Before I conclude, 2 things. Definitely watch the video that I provided. It's a nice lecture. And then definitely read about logistic regression if you are interested in knowing more on the algorithm. If I were to cover that, it'll take me at least 45 minutes to kind of go through each aspect of that algorithm. That's not the whole goal of this course, so I haven't done that. But if you're interested, definitely go for it. It's a nice little algorithm, logistic regression. All right, so hope you liked it. See you in the next lecture. Bye. Hey folks, welcome back. So a quick rewind. What we did in the last few lectures were we saw how to create X, how to create your small y, and then pass it on to an algorithm. And particularly in the last lecture, what we saw is that how can we determine which algorithm is performing better, right, or is giving us more accurate predictions. And the way we did that was pretty rudimentary, I would say. What we did was we took the data that we already know. We know the inputs and outputs, and we just used the same inputs and compared if they are producing the same predictions as our outputs, right? So that's kind of a manual way of checking how you would do that. So we did that for k is equal to 1, 5, 8 and logistic regression. Now this is okay, right? But then the thing is that you're never going to have 150 rows and very small data where you can manually do this and manually check this, right? And that is why we need to do the same thing but in a more systematic way, right? And the framework that we use to do that is called as splitting the data into train and test. Now what that literally means is basically what we did manually, right? Now if you look at this particular table, this is the table that we originally had. This is the capital X and this is the capital Y, small y, right? This is what we have been using to kind of train our model and fit the model and so on and so forth. But now what I'm doing is that I'm saying that, okay, we have this rich set of data which has all the inputs and the correct outputs as well. Let's use the same thing to test which algorithm is performing more accurately. So what we're going to do is we're going to take this data and split it into two parts, right? So we have 5 rows and I say that, okay, maybe do a 70-30 split, right? 70% goes to X train and 30% goes to X test. So what we are saying is that when you split the data, use these 3: X train data, capital X train, and the outputs to train the model. Don't use all the rows, but just use a portion of the rows, maybe 70% of the whole data to train the model. Okay. Once you have done that, from the remaining 30% where the model has not even seen the rows, right? That would be a good test, right? So that's why we call it X test. From the remaining 30% of the rows, pass them as inputs and see what predictions we get. And the reason why I say see what predictions we get is we already know the outputs, right? So if the prediction is setosa, then we know that the prediction was actually the right answer, right? So this is the way that we can do it. So just to repeat, what we are doing is we are taking the entire data set and then making 2 slices of it. The first slice is, we're going to call it X train, say 70% of the rows, and we pass the inputs and outputs to the algorithm and fit the model. The next slice, we don't touch the outputs. We just pass in the inputs and let the algorithm predict the outputs. Because we already know the correct output, we can then compare and see whether it predicted correctly or not. And we can use the same technique for different values of k, different algorithms and so on and so forth. And then we can kind of choose which is the most appropriate algorithm for our use case. Now, there's a lot of words which I put into this, right? Splitting the data, 70%, 30%, then there is X-ray, next test, and all those things. Now, the good news is that Python already provides a framework for dealing with this situation, right? The train and test situation. So before we go there, this is how it will look diagrammatically, right? So we take X train and Y train. So that is this thing, this whole thing. And we pass it to the algorithm and let it study it. And once it has created the model, we take the X test, this one, these rows, just the inputs, not the outputs, and let it predict, right? Once it predicts, we're going to compare those predictions against Y test and see if the predictions were right or wrong. So that's what we're going to do. All right. So now to do this, fortunately, Python provides some inbuilt frameworks and techniques. So the first thing I wanted to show you was that it's called the train test split, right? And all it does is basically you can pass in your capital X and capital Y and tell it split this for me in maybe 30-70 ratio randomly, right? Randomly choose rows so that your test has 30% of the rows and training set has 70% of the rows. Just by passing in some parameters, you can do that. You don't need to do anything manually. So the way that it looks is basically something like this, right? You import this module, train test module, and just call this function, right? So you say that you pass in your capital X, capital Y, and say split. Here they have said a test size should be 33%, and so the remaining will be your training size. And the random state is nothing but any number you can put. It's used as a seed for randomization. So if you have a set of 150 rows, it will not take the first 80 rows as train and the remaining as test or something like that. It will randomly choose 70% of the rows. And for the algorithm, for the randomization, you can pass in some number that can use as seed value. Now don't worry about the seed value and all, just remember that you can pass in some random integer over there, and then it'll use that. So a pretty useful function, I would say. So let's see. All right, so let me actually open up my notebook. All right, so let me press B, enter, and then first thing what I'm going to do is I'm going to use the sklearn dot cross validation, and it was, I believe, actually I should use model selection. That's a new one. So model selection, and then this is import train test split. All right, so that is done, and then next what I need to do is I need to call the train test split, and then pass in my capital X and small y, and let's say my split size should be 0.3, and let's not use any random state for now, let's just leave it at there. And what it will return is it will return those blocks, right? So you have X train and X test, Y test, and Y train. So just look at the order in which I have passed it on. So it's X train, X test, Y train, Y test. Okay, so we can just go back to our documentation and see if we have everything correct. X train, X test, Y train, Y test, and they have just called this method which and then passed on X and Y. All right, so half of our work, so using 2 lines of code, pretty much whatever I said, like splitting the data and all is done using 2 lines of code. To press Control and Enter, and then it splits it. All right, so let's run some few tests, right? So if you see our original data, we can look at the shape. It had 150 rows and 4 columns in it, right? And then we basically said we're going to split that up. So let's see how it split it. So let's do print x underscore train dot shape, and then print x underscore test dot shape. Right, so we have said that our test size should be 30%. So yeah, training is 105 rows, and then the test is 45 rows. So you see that it has kind of split both of them into 2 different buckets, right? One is a 70% bucket used for training, another is 30% bucket which is used for testing it. And again, if you're curious, I can also show you how it split the y component. It's pretty much the same, right? So 105 and 45. All right, so we have that. Now let's continue with our journey. So what we are going to do is we're going to pass this X train and Y train into an algorithm. You can pass it to KNN algorithm, or you can pass it to logistic regression, whatever it is. We don't care at this point. Let us just take an example. All right, so I'm going to use, maybe let's do the logistic regression which we just created. So we have imported all the classes and things like that in our code before, so I'm not going to redo that whole thing. So I'm going to just use logistic regression, and this time to fit the model I'm going to use the logistic dot fit, and instead of passing capital X and capital Y, I just want to pass X train and Y train. Okay, once that is done, some error. Let's see. Maybe I misspelled something. Logistic, right? Logis. Okay, that worked. So it has fitted the model. Now I can go and predict it, right? So I'll say logistic reg dot predict, and we used to pass in some random inputs over here, but what we're saying is that now let's pass the X test, right? That is this portion of it, these values. So X test, and then whatever it returns, let's just store it into Y predict variable, right? All right, so that is done. So we have fitted that into we have trained the model using X train and Y train, that is 70% of the total number of rows that we have, and then from the remaining 30% we have asked it to predict. Now it has predicted and all the predictions are stored here, but the good news is that we also know the actual answers. It is stored in Y test, right? So merely if we compare our Y test and Y prediction, we will know whether how accurate our predictions are, right? And fortunately, there is also a simple way of doing that. It's called accuracy score, and if you look at the documentation, there is this accuracy score where you pass in the true values and the predicted values, and it will kind of compare both of them and tell you how many of those values match or don't match, right? It will give you a percentage score. So this is how it is done. So it's under the Scikitlearn metrics. You import the accuracy score module, and then you pass the true values and the predicted values. In our case, the true values is Y underscore test, right? That's where the actual values are, and the predicted values we just stored in Y underscore predict. And it'll just tell you that, okay, it'll spit out a score which will tell you that, okay, when I compared both the values, 50% of the times it matched, 50% didn't match, right? So let's do that. So Y predict has all those things, and then now I'm going to do from Scikitlearn import metrics, and I'm going to say print metrics dot accuracy score, and I'm going to pass in my Y test to be compared against Y predict. Look at the order also over here. Maybe I had some spelling error. Let's see. Okay. So it has a 97.777% accuracy, meaning if you compare both of them, 97% of the times it matched, right? So you can say that the logistic regression algorithm gives a accuracy of 97%. So let's make a note of that. Something like this, right? Now we can repeat that for different models as well, right? So let's do KNN equal to 1, right? You can use the same thing, same principles, the same framework we're going to follow. And just so that we don't waste too much of time, I have some code in my clipboard. So it's the same thing which we did, right? We did a knn.fit x and y, but we're going to do x train and y train, and then we're going to predict, and then we are going to compare the test value with the predictions and see how accurate our predictions are. So here it is 95% accurate. So I am going to make a note of that. All right, what was it? 95.55. Okay. All right, so if I just let's do one more, right, so that we have some data to play with. So let's do KNN5, the same thing that we did above. And if I do that, that gives 97.77. So now you're getting more closer to say that, okay, maybe KNN equal to 1 is not a, a good choice, but logistic regression and N is equal to 5 is giving me some good predictions or some accurate predictions. Now, let me slightly change something and show you how a simple parameter change can cause the prediction accuracy to go high or low drastically, right? And again, a prediction of 100% doesn't really mean it's an awesome algorithm. So when you actually read the internals of the algorithm, you will know more about it, but we will look at a few techniques in the coming lectures as well. So here what I'm going to do is I'm going to say that instead of 30%, use 40% and use a random state equal to something 4, right? Let's see if this makes a difference. So let me go ahead and execute this. Then our shape is this. Now see, it has split it into 40%. So our test size is 40% and 60% is your training size. Similarly, your Y train and Y test shapes change. Now let us do a logistic regression and let us look at the accuracy. See, the accuracy reduced now to 95% for logistic regression. Earlier it was 97%, right? So let's make a note of it. All right, so that we know what we're doing. So now it is 95%. So you see that the accuracy has reduced a little bit. Now let's do this. This goes to 95. This goes to 96. So like what did we, what can we see over here? The thing is that we saw 3 situations. One is with different values of K, the accuracy changes. Second is with different algorithms, the accuracy changes. And the third is with our training and test sizes and random number seed generations, the accuracy changes. So naturally, there must be some sweet spot between these three main variables where we can try out a lot of values, and there will be a sweet spot where we can say that for K is equal to this thing for this algorithm, when the test size is say 0.4 and random state is this is the maximum accuracy you are ever going to get, right? So the most optimum values is test size maybe 0.4, random state is 4, and KNN equal to 5. That is what fits for your particular input, and this is the algorithm you need to use, and that is the best accurate algorithm you're going to have in this suite of algorithms that you're trying to do, right? Now that sounded like a lot, but by now you must have realized there are frameworks for it, right? So basically what I'm trying to say over here is a lot of factors are involved in choosing and fine-tuning a particular algorithm. I just showed you the different possibilities, right? Different possibilities of making some changes, and more importantly how you can split into train and test, right? And then get some good estimates for predictions. All right, so before we go further and then go a little bit more deep dive into considering all these factors and finally choosing an algorithm and a value of K or a value of random state and so on and so forth, I want to do a few things, right? You know how to calculate the accuracy scores by now, by splitting into X train X test and Y train Y test, and then you have the sample codes which I showed you. Can you repeat that for N is equal to 1 to 30 and tell me what value of N gives you the highest accuracy? You can assume any state for your your test split and your random state and all, and keep it consistent for all the 30 values. That's fine. The idea is, can you do that? And if you remember, in one of the assignments in the previous lectures, I had kind of asked you guys to take a stab at learning the looping constructs in Python, so that in one shot you can actually fit in the KNN algorithm for values 1 to 30 in a loop, right? Now do the same thing, but display in a table or even a graph, the accuracy values. Second is basically the same thing, right? For k is equal to 1 to 30, plot it on the x-axis, and whatever is your accuracy score between 0 and 1, plot it on the y-axis. So there's a documentation I have given. It is very simple, 3-4 lines of code, and then you can get all these cleanly plotted out in a graph, right? We are going to discuss a deeper variation of what I explained in this lecture, right? We're going to take it a step further and get a more refined framework to choose your algorithm and your parameters, and it's called the k-fold cross validation. Just so that it's not too overwhelming, I would strongly suggest that you first read this, right? Get an understanding of this, and because it will be incremental to this lecture, so it shouldn't be that difficult. But having some pre-reading helps. And then try to take a guess on what are some of the disadvantage of this method that I asked you, right? So one of the things is, definitely I showed you the random state variables. If you just change a little bit here and there, the accuracy scores change. So if you can think of more disadvantages, please mention it in the forum or in the form of comments, so that you can share your knowledge on this. So I hope you're getting more closer to developing data science, fitting models and choosing algorithms and stuff, and hope you're liking it. And as usual, please feel free to visit my website www.rakeshgopal.com, and then definitely send me your questions and stuff via forums, and tell me what you like, what you don't like, and is the speed okay. So we'll see you in the next lecture. Thanks for joining in.
Hello and welcome back. I hope you're enjoying all the videos so far. We looked at a lot of things in creating a data science model. We looked at how to pass on your inputs and stuff like that. So here we are going to take one step further. All right. So a quick rewind of what we did so far. We looked at how to calculate our capital X and small y, right? We looked at the input matrix. We also saw how to split that capital X and small y into training and test sets, right? And then what we saw was that we supplied the inputs to different algorithms. We saw the KNN algorithm. We tried with n is equal to 1, n is equal to 5, n is equal to 8. Then we tried another algorithm called logistic regression. And what we did was that we calculated our accuracy scores, how accurate is our predictions. And we saw that for each algorithm or for each parameter within an algorithm, the accuracy score varies, right? And that was one of the primary reasons where we thought that maybe if we split our inputs into a training and test set, we may be able to improve that situation. Now comes the question of, given that for any algorithm we choose, right, our accuracy scores may vary, or given the way that we choose our training set and our test set or the sample sizes, our accuracy scores vary. Is there a more systematic way to handle all of this? Like, we have the input data with us, we know what algorithms we are going to run. All we need is some sort of help in which we can say that, hey, I have this set of 10 algorithms, I have this set of input data. Can you suggest me which algorithm will give me the most accurate results for my given set of data? And that's precisely what we're going to look at in this particular lecture. So imagine a situation like this, and I just like these kind of diagrams where it oversimplifies stuff. Let's assume that you supply your capital X and small y, and along with a list of all algorithms that you want to be tested, right? So you supply KNN with n is equal to 1, n is equal to 5, logistic regression,
maybe decision trees, and so on and so forth. You just give a list to something called as k-fold cross validation. Just think of it as some sort of a framework, right? And what that framework does is it basically gives you an output which says that, hey, I have studied all the inputs and the different algorithms, and I have run some variations, and for your given set of data, use knn with n is equal to 5, right? That is the maximum accuracy that you're given the information that you have supplied to me, right? So that is what we are going to see in this particular lecture, right? So Python gives us so many tools. Scikitlearn gives us so many tools to kind of deal with such situations, right? So we are going to do that in this lecture. All right, so this particular technique is called as k-fold cross validation. Now, what exactly is this? So I have a Wikipedia link, and let me quickly go there. And if you remember, what we did with our capital X and small y is we split them into training and test sets. And if you need to take a break here and rewind and then watch my previous lecture, please do that, because I'll not be explaining what is a training set, what is a test set. It's pretty simple. So imagine that this is your input diagram, right? This is your input data. Each ball over here represents one row of data, right? So here there are about 20 rows of data. In our IRIS data set, we had 150 rows of data. What cross-validation, k-fold cross-validation does is it chooses the test data and training data, right? And tries different combinations of that. So in iteration number 1, you see the first 5 rows is treated as test data and the remaining is treated as training data. In the next iteration, it will choose the next 5 rows as test data and everything else as training data. In the next one, it'll choose the next few rows as test data and everything else as training data. So you get the picture, right? So all it is doing is, instead of just randomly choosing 5 rows and test data and training data and then supplying it to an algorithm and saying, hey, the accuracy score is this much, what it is doing is it is basically playing around with different combinations of test and training data, so that it's able to test it with the algorithm as to, if the training set keeps changing, how does the accuracy score change, right? And think of it this way, right? When it chooses the first time, when you choose the training data, maybe it chose the best set of data and the algorithm really worked fine with that data and the accuracy score was 98, right? And would you go ahead and choose that algorithm? Well, maybe not, right? But this particular technique will at least choose different combinations and permutations of training data and test data, and depending upon those different iterations, it will basically give you a accuracy score. Like for iteration 1, the accuracy score may be 98. For iteration 2, the accuracy score may be, say, 94. For iteration 3, the accuracy may be, say, 95. So if you have k is equal to 4, you'll have 4 iterations. And basically you can just then take a mean of all the accuracy scores and say that for this particular algorithm and for this particular set of inputs, the mean accuracy score is whatever, say 95, right? And you can repeat the same with another algorithm. You can repeat the same with another algorithm. So playing around with different combinations and permutations of input will actually give you a better accuracy score, so that you can make proper judgments. All right, so I would strongly encourage you to read this whole thing. It's a wonderful article here, and I have actually given you a link in the further reading section as well. All right, so that was about it. And what about some code, right? So there is this particular set of code that we're going to write now, and it's kind of called cross validation. Okay. And don't worry too much about it. I have given this link as well in the reading section, but it's precisely the same things that we discussed right now, right? It's going to basically use some permutations and combinations of the input
and then we'll pass it to the algorithm and get some mean scores with it. All right, so let us go ahead and write some code. All right, so what we are going to do is we are going to import the cross-val score module, and let me just quickly do that from sklearn.model selection. I'm going to import the cross-val score, right? And what we are going to do over here is we are going to run the k-neighbors classifier, KNN algorithm for say k is equal to 5. We have seen that in the previous lectures, right? So we ran some basic algorithm where we say we instantiated the class and n is equal to 5, and we fit the model and done some predictions with it. So we are going to precisely do that. So let me go ahead and do that. So let's say KNN equal to k neighbors classifier and n underscore neighbors equal to 5. Okay, so I have an instance. Just make sure that I spell this correct. Is there some other issue? Okay. All right, that worked. So we have an instance of k neighbors classifier, and what we are going to do is we are going to use the cross-val score, and we're going to pass in KNN and see that, okay, for my set of inputs, which is capital X, and predictions or outputs that are small y, run the k fold 10 times and score based on accuracy, or give me the accuracy scores, right? And I'll store this in say scores. Now what this does is, this is precisely what we talked about, right? We said that we'll, for an algorithm, use different combinations, use 10 iterations of different combinations of test and train, right? So use this X and Y and split them into test and train in different permutations and combinations up till 10 times. And for each run, give me the accuracy score, right? And for each run, the accuracy score will be stored in scores. So let's see what happens here. So it ran that, and if I just say print scores, it's going to give me the accuracy score. So the first run, the accuracy score was 100%, then it was 93%. For the third combination, it was 100, fourth it was 100. So you saw that different combinations of input, right? Different combinations of input produces different accuracy scores, and this is precisely what we wanted, right? Imagine that we took the X train, right? We took a particular combination of training and test set such that it is similar to what it matched in number 3. We'll get 100% accuracy score, and then we say that, hey, this algorithm is awesome, this is the most, it is giving me 100% score, so I'm going to go ahead and use it. And when you actually run it against a few production data, you'll suddenly see that the scores are going down, and you'll imagine that, well, this was giving me 100%. Well, yes, that is true, but for that combination of training and test set, it gave you 100, but we'll have to try out for different combinations, right? And that's precisely what we did, and we got 10 scores. So what I'm going to do is I'm going to take the mean score of this. So for this algorithm, based on 10 iterations, I can say that this algorithm produces approximately 97% or 96.6% accuracy, right? So this was for k is equal to 5. Now if you remember, I had asked you to actually compute the accuracy scores for k is equal to 1 to 30, right? For in the KNN algorithm, we used k is equal to number of neighbors equal to 5, but you can choose number of neighbors equal to 1 and then run the cross validation, right? So for number of neighbors equal to 1, we'll run 10 different combinations of input and get the mean score. Similarly, for number of neighbors equal to 2, again 10 different combinations and get the accuracy score. So basically that is why I asked you to practice that looping construct, but nevertheless I can kind of show you quickly how it is done. So what I'm going to do is, first of all, I'll just define a
I'll just define a k range, and what I'm going to do is I am going to run this knn for number of neighbors 1 to 45. Okay, so that's pretty much what I'm going to do. So what I'll do is for k in k underscore range, let's say run k neighbors classifier where n underscore neighbors equal to k. So in the first iteration, k will be equal to 1. So you'll run knn algorithm with number of neighbors equal to 1. And when it is 1, make sure that you compute the scores, cross val score, for the knn where n is equal to 1, for my input x, y, perform 10 permutations and combinations and give me the scoring accuracy. Right? So I hope you're understanding that for nearest neighbor, k nearest neighbor, n is equal to 1, it will run 10 combinations of input, give me the mean score. Then it will proceed to n is equal to 2, 10 combinations of that and give me the mean score. So basically what I'm doing is I'm testing this for which particular value of k, right, in this knn algorithm gives me the maximum accuracy, right? So and then I need to store these values, right, somewhere. So I'll just define an array called scores, and then I'll just store it in that k underscore scores dot append, and I just want to store the scores dot mean, right? All right, so this ran, and then let me go ahead and just print this. Let me go ahead and print this. All right, so you saw that for 1 to 45 it is giving me all the mean scores. So when k is equal to 1, it's split into 10 permutation combinations and the mean score was 95.9% accuracy. Then it was 95.3% accuracy. Then it was 96 points. So this is for k is equal to 1, this is for k is equal to 2, this is for k is equal to 3, and so on and so forth, right? So for k is equal to 1 to 45, you've got all the accuracy scores now. So now it is very easy for you to choose what value of k can you use to identify the accuracy scores. And there's actually a better way of doing it, and I kind of like the pyplot tutorial. So let me quickly show you that. So this is, I have given you the link of that as well. So it is in the matplotlib.pyplot, and it basically you can give the x-axis values and y-axis values and it'll plot a nice graph over here, right? So we can kind of in an x-axis we can plot k is equal to 1 to 45, and y-axis we can plot the accuracy scores, and it will quickly give me a sort of a line, and then visually we can identify which is the best algorithm, right? So let me go ahead and do that. So the way it is done is, I don't know the code by heart, but import. Okay, let's do this. Let's copy paste this. All right, and then I need to make sure that matplotlib dot pyplot as plt, right? And I'm going to just say plot. My x-axis should be your ranges, that is from 0 to, so from 1 to 45, and my y-axis is my scores. Let's see if that worked. Let's see, matplotlib dot pyplot. It gave me an error, but still it worked for some reason. I know, probably because of this. Okay, so
it kind of, actually, let me also make sure that I put some labels, right? And this could be K value for KNN algorithm, and this can be Y label, this can be mean accuracy scores, right? So gives you all these values. So looking at this, you can see that for K is equal to 20 and something around 18 and 12, you get the maximum accuracy scores, right? And the higher value of K, it's better. So in this case, we see that for our given set of inputs, if we use KNN algorithm, the best value of K, which gives us the maximum accuracy scores, is K is equal to 20, right? So given X, capital X and Y, we have now used a very, very systematic method to calculate which particular algorithm gives us the maximum accuracy. Okay. So I know this was a little bit of too much of a deep dive. I've tried to simplify this. I would recommend you to that you watch this lecture again in order to get some idea. And I would also challenge you to extend this a little bit, and we just looked at a couple of parameter within the same algorithm. I would challenge you to use multiple algorithms, right? Logistic regression and KNN, and from that you should be able to choose which is the best algorithm. It's just an extension of this, right? So I would challenge you to do that, and as an assignment, as a quiz, as a homework. That will help you to understand these concepts even better. So I hope you like this lecture. This was a little bit more deep dive, and in the coming few lectures we will take a deep dive into some more complex concepts, and slowly you will be in a position to evaluate algorithms, choose algorithms, evaluate your inputs and stuff like that. All right, so see you in the next lecture. Bye. Hello everyone. So finally we are getting to the end of this whole module on data science and analytics. So let me spend a few minutes walking you through what all we covered in the last few lectures. So first of all, we started with what is data science and analytics, right? We didn't assume that anyone has some prior knowledge. We walked through some absolute basics. We looked at some concepts of data science, analytics, what it is all about, right? And then we kind of went a little bit deeper into it and saw what is supervised and unsupervised learning. Again, just a little bit on, just to get ourselves informed on that. Then we looked at the Anaconda distribution of Python, and then we looked at some tools in which we can start typing some code. And then we kind of generalized this whole pattern, right, of how a data science algorithm really works, right? So we saw a general framework, right, where we said that, okay, we have a set of data. We kind of use some numerical and numpy arrays and put it into capital X and small y, and then supply it to an algorithm where it kind of studies that, and then we are able to make some predictions, right? So those were the few things we covered. And then in the further lectures, we looked at, how to kind of, split your data into testing and training, so that, you can kind of train the algorithm with some data and then test it for accuracy. We saw some frameworks to calculate accuracy. We saw some ways in which we can run some loops and then find the best parameters that can be used for your algorithms. Now, what exactly are the next steps? And just to be very clear, the idea of this was not to go to a level where you become an absolute expert in data science, but at least to give you enough idea so that you can make a choice whether data science is for you or not, right? And by this time, you must have realized that it's frankly nothing rocket science, right? It's basic statistics that you need to learn. You need to learn the domain that you're working on. You need to learn how the inputs interact among each other. So you must have kind of the idea was to get a feel of what is data science and how it actually looks like when somebody says, I'm fitting a model, I'm working on a data science project, I'm a data scientist. What are they really doing, right? So again, this is like very, very high level that I have explained. So you can kind of consider this as module number 1, where we just touch the surface of it, like absolute basics of data science, right? We looked at Python and stuff like that. Now, naturally, I can record more modules where I go into more complex stuff, right? There's something called as pandas and data manipulation. Now, this is basically, I wouldn't really call this as pure data science, but it helps your data science projects a lot, right? So it actually deals with how can you manipulate and clean up the input data. So most of the times you'll be given input data as a CSV file or very, very huge files, and then you need to kind of clean that up. Not all the columns would be super relevant for you. And if you remember, in one of the examples we talked about the email, where the email message is your input, we took that and created further inputs, right? We saw how many spelling errors are there, how many external links are there, the to address, from address. So we created our own inputs. So all that input data manipulation, etc., there are some solid frameworks in Python. So I can kind of even create a separate course just that deals with that. So those will be your tools towards getting to a more complex data science learning. Then naturally, if there is enough interest, I can just create some courses on statistics, right? So here the idea won't be to get too much into coding and stuff, but to kind of understand what is linear regression, right? In terms of equations and math, how does it look like? What exactly is linear regression? We'll take some sample data and kind of plot an x and y axis, draw some curves and see what is the general equation that makes it up. And again, if there is general interest on that, I can definitely make some videos towards that. But then there is the second aspect of this, where you kind of know enough of these algorithms so that you can go ahead in Python and kind of apply these algorithms to your inputs, right? So there are lots and lots of algorithms, and it's kind of impossible to cover each and every algorithm. But what we can do is we can kind of take the top 10 algorithms that are commonly used, and so that you get a general understanding of what these algorithms do, how do they interact with data, and for a certain type of data, which algorithm should be even considered. And given a set of 5 or 6 algorithms, how can we evaluate which algorithm works best for your given set of input data? We kind of saw a little bit of that in this particular course, but that's the whole essence of it, right? We will keep building up.